Hello everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. Today in this lecture video series we are going to discuss ANOVA. In that we are going to discuss completely randomized design. So this is also known as CRD. So this is the most basic and foundational design of experiments, and in CRD, a common completely randomized design, we assign treatment to experimental units purely at random. So there is no restriction or no grouping and no blocking, just complete randomness in this method. So this design is best suited where all experimental units are homogeneous, that is, they behave similarly under experimental condition. So here are the fundamentals in which we see arithmetic average, median, mode, standard deviation, variance. So these arithmetic mean, median, mode are called central tendencies, where this arithmetic mean is nothing but the average value of all the data given. For example, if we are given with 10 data, the total divided by the number of entries gives the average, and median is nothing but the mid value, and mode is nothing but the most repeated value. Similarly, the standard deviation is nothing but how deviated the particular value from the average, and variance is also. So when we know this, we can frame the data. So here these experimental units, we have to know about this. So the experimental units are an object on which we perform the experiments. So then we have to know about the treatment. So treatments are different conditions applied. So when different conditions are applied, we call that as treatment. Next is the response variable. So the outcome which we measure is called the response variable. Similarly, let us consider one example for if we test a fertilizers on plant, then the plant will be an experimental unit, then fertilizers will be a treatments, because we can use different types of fertilizers. Next, yield of the crop is a response. So then now the question is, how do we assign fertilizers to plants without bias? So we can use this CRD method. Next is an empathy part. So empathy, what do you mean by empathy? Empathy is about knowing the user needs. So let us understand the real world problem. So imagine a laboratory experiment where all test samples are identical. So here the researcher wants to compare three drugs. So he have to have the concern like avoid biasness, ensure fairness, maintain simplicity. So since all samples are similar, there is no need to group or block. Next, so the simplest solution is assign treatments randomly so that we can. So the next is define part. So the define part is nothing but to define the problem statement. For example, so we define for example, if we have compare multiple treatments to ensure that unbiasedness allocation, avoid systematic error. So the key assumptions in CRD are all experimental units are homogeneous, therefore we can apply CRD method. So any variation is due to random error only, so we will find the randomness also. So the next is an ideate part. So here in this we can see what we are going to identify. So now let's design the experiment. The first step is to identify how many number of treatments are there. Here we have only one treatment, so that is teaching methodologies. To see the variances in teaching methodology, so totally there are three teaching methodologies. First one is A, B and C. So next, decide the number of observations. So the how many observations are taken. Next, assign treatments randomly. So for example, if we have 4 treatments and 20 units, each unit randomly gets a treatment. Next is randomization method. So here there are lottery methods, random number table methods and software tools, etc. Next is a prototype. So to see this prototype, this is a table in which we finalize or we conclude the solution, or we give the conclusion for the assigned problem. For example, the first one will be the source of variation. Mostly the first one will be along columns. So since we will be taking each and every treatment in one column. For example, teaching methodology A will be taken as x1, teaching methodology x2 will be taken as x2, and teaching methodology C will be taken as x3. So the first one will be columns. Next, within the group errors, then degrees of freedoms will be how many total teaching. So here there are 3 teaching methodologies, so 3 minus 1. Next, the degrees of freedom will be n minus k, where n is the total number of entries, minus k is nothing but the number of treatments. So next is the sum of squares. Sum of squares are nothing but sum of the square of columns, so which will be calculated using the table. Next will be sum of the square of errors. So this will be calculated using TSS minus SSC. Next is the mean sum of the squares. So the mean sum of the squares are nothing but the sum of the square of corresponding, for example, if you are seeing for columns MSC, that will be calculated by using SSC divided by the degrees of freedoms of the columns. So and for errors also it will be calculated accordingly. Next, F ratio. F ratio is nothing but the ratio of mean sum of the squares with errors, mean sum of the errors. So here we are having only column, so MSE divided by MSE. MSE is the mean sum of the errors. So if we find out that errors are greater than the columns, then it will be shifted accordingly that MSE divided by MSE, since the F ratio should be always greater than 1. So the conclusion will be given in such a way that if F ratio calculated is greater than the F ratio tabulated, then we will reject the H naught. If calculated value is less than that of the tabulated value, then we will be accepting the H naught. So here are the few applications of CRB method. So first one is in agricultural field. So uniform land, like example we have seen the fertilizers we can use. Next, in medical trials, controlled lab conditions are tested. Next, standardized materials, this will be used in industrial testings. So here what is an advantage of this method is that this is very simple and easy to analyze. So if we have any advantages, then there will be a disadvantage also. So this method cannot be used for heterogeneous number of units. So next is the small mind map of what we have discussed in this video. So initially we have seen what are all the basic units of ANOVA. Next we have discussed about CRB method. Next, assumptions. Next we have seen how to accept and reject H naught, and this is purely based on the design thinking concept. So here is the few assessment questions. So in CRD, the total sum of the squares is partitioned into treatment and block essays, block and error, treatment and error, row, column and error. So here only we having treatment and error, so the option C is the correct. Which of the following is the limitations of CRD? So difficult randomization, not suitable for heterogeneous, complex ANOVA, requires equal replications only. So since we have seen a few minutes before that for suit heterogeneous methods, heterogeneous units, CRD won't be suitable. So the option B is the answer. If there are 4 treatments and 20 observations, the error degrees of freedoms will be 20 minus 4, that is n minus t. So therefore it will be 16. Here are the references for this PPT, and thank you.